Purpose of this video is to demystify specific heat capacity calculations, give you an approach to solve all equation-based problems, and give you practice to build confidence using these equations with step-by-step solutions to help you with your confidence. So when you see the symbol on the top right of the screen to pause the video, I suggest you pause the video, have a go at the question yourself, and when you're ready, go through the step-by-step solution. So let's start by having a look at the equation. The equation is based on this idea that specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So if we look at that in words, it's the change in the thermal energy, and that is due to the mass times the specific heat capacity times the temperature change. So if we've got a larger mass, it's going to require more thermal energy to lead to that change. If we've got a material with a larger specific heat capacity, that's going to require more energy. And if we've got a larger temperature change, that is going to require more energy than a smaller temperature change. Right, let's just check through the units here. Energy you should be familiar with is in joules, and the symbol being a J. Mass in kilograms, specific heat capacity joules per kilogram degrees Celsius, and degrees Celsius there. I've put both the units and their symbols there so that you can make sure you're familiar with that. And what you should see there as well is that all of those units are sort of work together to allow us to get those different parts. Make sure in your answers that we're starting in the right units. So the next thing that causes people problems is the use of delta. Delta is a Greek letter, it looks like a triangle, and we use it to represent change. Okay, so the two changes that we can use in this one is the change in energy, delta E, okay, and delta theta, which might be a little bit confusing because it's another Greek letter, used to represent change in temperature. So if we put that into an equation, you can see how the different parts are there, and I've used the colours so you can see which one matches with which. Change in thermal energy, delta E, mass, specific heat capacity, and delta theta for temperature change. You may also see it written like this, where we've got delta T to indicate the change in temperature, and with both of those, an easy way to remember that might be to think delta E is equal to mcat, where that capital A is a shorthand for that delta, that change. That may be useful to you. It may not. Okay, right, let's have a look at some calculations. So before we have a look at that, let's have a look at the equation process. The equation that we're using today is delta equals mc delta theta, or mc delta T. Okay, the change in energy is equal to the mass times the specific heat capacity times the change in temperature. In the question, what we need to do is we need to find the values that relate to that. We need to check that they're in the right units, so we need to check they're in kilograms and joules and degrees Celsius, not in grams and kilojoules. We need to substitute in these values into our equation. Then we rearrange if we need to, do our calculation, write our final answer, and the correct units for it. So that's a process that you can use with every calculation-based question. Okay, our first question here. You can pause the video here and have a go yourself, or you can watch on to see how it's solved. Right, so calculate the energy required for 1 kilogram of water to go from a temperature of 20 degrees to 80 degrees, and the specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. So firstly, as we said in our process on the previous slide, is that we're going to look at the change in energy, which is what we're looking to calculate. We've got a mass of 1 kilogram, right units. We've got our specific heat capacity in the right units, 4,200. And our temperature change, we're starting at 20 and our final temperature is 80. So our final temperature minus our start or initial temperature of 20 gives us a temperature change of 60 degrees Celsius. So write our equation, substitute in the values, calculate, and we get 25,200 joules. Okay, moving on to some questions for you to have a go at here. Pause the video here, have a go at those three questions, and once you've done that, unpause the video and we'll have a go at the solutions. Right, on to the first question. Welcome back. A steel ball has a mass of 0.5 kilograms. The specific heat capacity of steel is 510 joules per kilogram degrees Celsius. And how much energy is needed to heat the ball by 43 degrees Celsius. So that's a temperature change of 43 degrees Celsius. So if we put all those figures down, we've got it in kilograms, joules per kilogram degrees Celsius, and 43 degrees Celsius temperature change. So firstly, write out our equation. Secondly, substitute in those values. And finally, do our calculation to get our final answer of 10,965 joules. Question 2. Got a kettle, 600 grams, we'll have to think about that. We've got our specific heat capacity and we've got our initial and final temperatures. So if we put all that down, we're still looking to calculate the energy. 600 grams, so we need to divide 600 by 1,000 to get it into kilograms, okay, because there are 1,000 grams in a kilogram. That gives us 0.6 per kilogram. We've got our specific heat capacity, and then our final temperature minus our start temperature gives us a temperature change of 70 degrees Celsius. So again, we write out our equation, we substitute in our values, we do our final calculation, and we get 176,400 joules. Question 3. Right, we've got a start temperature, we've got a finish temperature. Start temperature 22, finish temperature 4. We've got the mass of the can and we've got the specific heat capacity. We're looking again for that change in energy. So again, grams to kilograms, we need to divide by 1,000 and that gives us our answer of 0.384 kilograms. We've got our specific heat capacity. Okay, our final temperature is 4 degrees. Our initial temperature was 22 degrees. 4 minus 22 is actually minus 18. Now this links into the question where it uses the word lost. Okay, so a negative indicates that we're losing energy and a positive number indicates that we're putting energy in. So that's an important thing for us to be mindful of when looking at these questions. There's our equation, substitute in our values, do our calculation, and we should get minus 26,265.6 joules, round to a whole number, minus 26,266 joules. The minus indicating that that is energy lost from the drink. Okay, great. Right, we're going to look at some rearrangement calculations here. A bit more challenging. You can pause the video if you like, or you can watch it on. Right, if we look at the question here, let's get out the information that we've got. Okay, we've got an initial temperature of 15. Okay, heats water to boiling. Okay, so boiling point is 100 degrees. So that's sort of a bit of information that you need to know, but hopefully you're all aware of that. Water boils at 100 degrees Celsius. 100 minus 15 is 85 degrees. We've got our 4,200 joules per kilogram degrees Celsius. We're looking to find the mass, and we've got this change in energy of 249.9 kilojoules. Hopefully you're familiar with the idea that if we've got a kilojoule, to turn it into a joule, we need to times by 1,000 this time, because we're moving to joules from kilojoules. Okay, so 249.9 times 1,000 is 249,900 joules. Right, now we get our equation. We substitute in the information that we have. So as you can see, all that's gone in there. And I've put brackets around 4,200 times 85. I'm not going to do my calculation yet. If you remember your basics of rearranging an equation, we're going to do the opposite to both sides of the equation. So on this side, if we're looking, we can see that they're being timesed by m. So we're going to divide both sides by that. That means that it's going to cancel out on the right-hand side of the equation, and we're going to be left with it on the left-hand side of the equation. So therefore we get our rearrangement like that. 249,900 divided by 4,200 times 85. And if we do that, if we work out what that answer is there, okay, we can see that, and we can just switch it around there to end up with m is equal to 0.7 of a kilogram. Often important to check our answers sort of make sense in the real world as well. A kilogram of water is equivalent to 1 litre of water, so 0.7 of a kilogram is that, 0.7 of a litre of water inside the kettle, which seems to make sense. It would be a reasonable answer to get there. Okay, so that's the first one done. Now we're going to look at specific heat capacity as the subject here. So you can pause the video or watch it on. Right, let's see what information that we've got there. 45 kilojoules, so that needs to times 1,000 to give us 45,000 joules. 10 kilograms in the right units. We don't have the specific heat capacity, and we've got a final temperature of 85 and a start temperature of 20. 85 minus 20 gives us a temperature change of 65 degrees Celsius. Put that information into our equation, and we can see here that we've got C there. What we can do is we can put that 10 times 65 together, and again, following the same process, divide both sides by that. It's going to cancel out on the right. It's going to leave us with it here on the left, and we're going to get 45,000 divided by 10 times 65, okay, which is 45,000 divided by 650, which is going to give us a specific heat capacity of 69.230 carry on, which we're going to round to 69 joules per kilogram degrees Celsius. Okay, so that's that one done. Right, making temperature change the subject. So not got much information here, but hopefully you can recall some of the information from past slides and able to work that out. So pause the video now if you want to have a go on your own. And let's now go through that. So we can see here that we've got the change in energy, thermal energy of 2,100 joules. We've got a mass of 0.2 kilograms. And we've got specific heat capacity of 4,200 joules per kilogram degrees Celsius, which hopefully you should recall from all the previous questions that we've done on that. We haven't got the change in temperature, so we've got our equation. We're going to put the values in that we have. Again, using that same idea of just keeping those two values there. Divide by through on both sides. It's going to cancel out on the right hand side. It's going to leave us with it there under the left hand side. So the change in temperature is going to be 2,100 divided by the product of 0.2 times 4,200, which is 840. 2,100 divided by 840 is going to give us an answer of plus 2.5 degrees Celsius. So that is our temperature change there. Hope you found that useful. If you have, please subscribe to the channel. We're going to have more content going on. Please make sure that you subscribe, you share, and if you've got comments, if there's something I've not explained particularly well, or is there something you'd like me to go through, please let me know and I'll do my best to do that. Thanks very much for watching.